In topic 4.6, we are going to learn how to find the discriminant of a quadratic function or equation, and by using the discriminant, you can determine the types of roots and the number of roots that the equation will have. Remember, roots is another word for solutions or x-intercepts or zeros. So, remember your quadratic equations are the ones with x squared. They're usually written in the form ax squared plus bx plus c. The formula to find the discriminant is discriminant d equals b squared minus 4ac. And if you know the discriminant, you're able to tell the number of roots or solutions your equation will have, as well as what type of roots they will have, if they're real or if they're imaginary. Remember, if they're real, you'll see the x-intercepts on a graph. If there is imaginary roots, it'll look like there's no x-intercepts. So if your determinant is less than 0 or negative, then you're going to have no real roots. You're going to have two imaginary roots. On a graph, that would look like a parabola that has no x-intercepts. If your determinant is equal to 0, then you're going to have one real root. That would look like a parabola with a vertex on the x-axis. And if your determinant is greater than 0 or positive, then it will have two distinct real roots. In other words, two real roots. On the graph, that would be a parabola that crosses through the x-axis twice and has two x-intercepts. So what we're going to be doing here is we're going to be using the formula for discriminant to find the value of the discriminant and then to use it to describe the types of roots each equation has. So here in number 1, I'm going to start by labeling my a, b, and c. My a is 6, my b is 7, my c is negative 3. A is always the number in front of x squared, b is always the number in front of x, and c is always your constant. And now I'm going to plug into the formula for discriminant, which is b squared minus 4ac. So for b, we have 7, a is 6, c is negative 3. And I'm going to start to simplify this or make it smaller. So 7 squared is 49. Here I can do this chunk together. 4 times 6 times negative 3. So 4 times 6 is 24. And then 24 times negative 3 would be negative 72. So here I'm going to put a negative 72. And remember, when you're subtracting a negative, that really changes to addition. So this becomes 49 plus 72, which is equal to 121. Now, this is a positive number. So since it's positive, that means we're looking at our notes for positive up here, that our parabola is going to have two distinct or two real roots. So positive will be two real roots. On question 2, I'm going to start by labeling my a, b, and c. Here I can put an imaginary 1. So my a is 1, my b is negative 6, my c is 25. And then I can plug this into the formula for discriminant. So I have negative 6 squared minus 4 times 1 times 25. This becomes 36 minus 4 times 1 is 4, and 4 times 25 is 100. If I do 36 minus 100, I will get 64 as my answer. So this is the discriminant. And since this is negative 64, and since my discriminant is negative, if we look back at our notes here, negative discriminants have two imaginary roots. So this one will have two imaginary roots. So the main thing to remember for now is if your discriminant is positive, your roots are real. If it's negative, your roots are imaginary. Let's go ahead and look at this last example. Here my A is 4, my B is negative 20, and my C is 25. And I'm going to plug into the formula for discriminant. So I have negative 20 squared minus 4 times 25. That's 400 minus 4 times 4 is 16. And 16 times 25 is 400. So this becomes 400 minus 400, or 0. If the discriminant is 0, that means our function's only going to have one real root. So just to summarize, once you do get your discriminant, if it's positive, you have 2 real roots. If it's negative, you have 2 imaginary or complex roots. And if it's 0, you'll have 1 real root.